Hi, welcome to my video on proofs with complementary, supplementary angles and vertically opposite angles. Proofs with complementary, supplementary angles and vertically opposite angles. The definition of complementary angles: two angles whose sum is 90. 60 is the complement of 30 because they add up to 90. The complement of 27 is 63 because they add up to 90. Notice the two AC is perpendicular to a CB. That means angle 1 will add up to make a 90. So that means angle 1 is complementary to angle 2. Supplementary angles, two angles whose sum is 180. 130 is the supplement of 50 because they add up to 180. The supplement of 45 is 135 because they add up to 180. Notice in the diagram, it says AC is a line segment. Angle ABC is a straight angle, very straight across. That means that 1 plus 2 is 180 because they add up to a straight angle. Straight angle is 180 degrees. And that means that 1 and 2 in this diagram are supplementary because they form a straight angle adding up to 180. A little tip on how to remember complementary and supplementary. Complementary sum is 90. Supplementary sum is 180. So the way I remember it is C is before S in the alphabet, so 90 is before 180. So complementary is 90, supplementary is 180. So let's look at a couple of theorems. It's the complement of equal angles or the same angle are equal. It's called a CAT, complement angle theorem. Complements of equal or congruent angles or same angle are equal. Even though we use this statement, let's do the proof on this. So we have complementary angles that are equal. So notice I'm given that 1 is complementary to 4, 2 is complementary to 3, and 1 is equal to 2. So the complements of equal angles are equal. So let's write down number 1. Angle 1 is complementary to angle 4. Angle 2 is complementary to angle 3. And angle 1 equals angle 2. So let's write that down as a given. Angle 1 equals angle 2. Because we have that they're complementary, that means that angle 1 plus angle 4 is equal to 90 degrees. And angle 2 plus angle 3 is equal to 90 degrees. And the reason for that is the definition of complementary angles. Complementary angles add up to 90. Because the two pairs add up to 90, that means that angle 1 plus angle 4 is equal to angle 2 plus angle 3. And that's both of these pairs, 1 and 4 and 2 and 3 add up to 90. Therefore, 1 plus 4 equals 2 plus 3. And that's called that the transitive property of equality. And notice now that we have given that 1 is equal to 2. So because 1 is equal to 2 and they're on opposite sides of the equation, that means 4 is equal to 3 by subtraction. Subtraction property of equality. Again, I'm not writing down equality. So we have proved that if two pairs of angles are supplementary and they're two equal angles, then the other angles are equal also. And this is the same for supplements of equal angles or same angles are equal. It's called the supplement angle theorem, SAT. I will use that in my proofs. So, same again, we're given two pairs of supplementary angles. So we're given that angle 1 supplementary to angle 4. Angle 2 is supplementary to angle 3. and we're also given that angle 1 equals angle 2. So that's the given. If I can spell right, G-I-V-E-N, given. And that's number 1. Number 2, because they're supplementary, angle 1 plus angle 4 is 180. And angle 2 is supplementary to 3, so 2 plus 3 is equal to 180. And that's the definition of supplementary angles. Supplementary angles, if angles are supplementary, add up to 180. And because they're both equal to 180, that means angle 1 plus angle 4 is equal to angle 2 plus angle 3. And again, like before, it's a transitive property. They're both of these pairs of angles are equal to 180. Therefore, 1 plus 4 equals 2 plus 3. Transitive property, P-R-O-P. And number 4, we have 1 is equal to 2 again. So that means that angle 4 equals angle 3, and it's called subtraction again. So now that I have proved subtraction, CP as an N, now that I have proved it's called the CIT, complement angle theorem, supplement angle theorem. So if you have two pairs of complementary angles and the two angles are equal, then the other angles are equal. And that's the same for supplement angle theorem. I will use this SAT in my proof to show you how it works. I don't have to prove this anymore now. I already proved the CAT and the SAT. And we have another pair of angles. We have the definition of a linear pair of angles. Two adjacent angles forming a line segment or a straight angle. That's two adjacent angles forming a line segment is said to be a linear pair. And notice they're forming a line segment or a straight angle, and a straight angle adds up to 180 degrees. Two adjacent angles are supplementary. Because they add up to 180, these two adjacent angles, 1 and 2, are supplementary. So angle 1 and 2 are a linear pair because they form a straight angle. That AC is a line segment or a straight angle. That means 1 plus 2 are supplementary. They add up to 180. Okay, a linear pair. When you see a diagram and you want to say two angles form a straight angle, then we have a linear pair. So from the diagram, 4 and 5 are linear pairs. 1 and 6 are a linear pair. So 4 and 5 is a linear pair, 1 and 6 is a linear pair. That means that 4 and 5 are supplementary to each other. 1 and 6 are supplementary because they form a straight line, a straight angle. They're a linear pair and they're supplementary. I would use that in my proofs. And another theorem that's in our proofs is called VOAT, or some people might call it VA, vertical angle theorem. I call it the vertically opposite angle theorem, but some people call it the vertical angle theorem, VAT. That is, if two lines or two line segments intersect, then the vertically opposite angles are equal, or the vertical angles are equal. So in this diagram, I have AB and VT intersect A, B, and VT intersecting at O. And as a result of these two lines intersecting, then 1 equals 3. The angles across the vertex, opposite each other, are equal. 4 equals 2. So 1 equals 3, 2 equals 4, 4 equals 2, because they're across from each other, across from the vertices. And let's look at a proof for that. Now let's prove that the vertically opposite angles are equal. When we have to do a proof, we have to do it in a roundabout way. So here we go. So we're given that two lines intersect. So we're given that PQ and SV intersect at X. So P, Q, and SV intersect at X. And that's given. Okay. Number 2. That means that we have to, how are we going to do this proof? Well, we just said that angle 1 and angle 3 are a linear pair. And angle 3 and angle 2 are a linear pair. And that's the definition of a linear pair. What's a linear pair? Well, this is a linear pair because it's forming a straight angle, or adjacent angles that are making up a straight angle or a line segment. That means if 1 and 3 and 3 and 2 are linear pairs, that means that angle 1 is supplementary to angle 3, and angle 3 is supplementary to angle 2. And that's because we have I'm going to call it STR for straight angle, abbreviation for straight angle. So we have, if that's a linear pair, that forms a straight angle. That means they're supplementary. And because they're supplementary, that means that angle 1 plus angle 3 is 180, and angle 3 plus angle 2 is 180, and that's the definition of supplementary angles. Angles that are supplementary add up to 180. And because they add up to 180, that means that angle 1 plus angle 3 is equal to angle 3 plus angle 2. And that's transitive. So we're proving it in a roundabout way. Now we have that angle 3 is equal to angle 3, and that's what we call the reflexive property. Remember, reflexive property is that a number is equal to itself, an angle is equal to itself, so 3 equals 3 is reflexive. Now, because we know that 3 equals 3, that means that angle 1 is equal to angle 2 by subtraction, property of equality. Again, you have to do it in a roundabout way. But now, we have proven this. So in any proof, when you're asked to prove it, you have to prove it this way. But if you're doing a proof and you need to use this, then we can use, if we see two lines intersecting in a proof, we can say that 1 equals 2 by VOAT or VAT, because we've already proved it. Let's continue with another example of a proof. We have a diagram, as you can see, and we're given that angle 1 is equal to angle 2. So that's the given in our proof. Let's write down the given. So how am I going to get that 1 equals 3? Well, if 1 equals 2, I know that 2 is equal to 3 because these two lines intersect. These vertically opposite angles are equal. So you can call it VOAT or you just VAT. You ask your teacher, I call it vertically opposite angle theorem, or you just call it vertical angle theorem, your choice. But check with your teacher. And as a result, angle 1 equals angle 2, angle 2 equals angle 3, so angle 1 is equal to angle 3 by transitive property. Angle 2 is equal to 1 and 3, transitive property of equality. Again, transitive property, and your teacher might want you to write out transitive property of equality. Well, I'm just not putting it down, but check with your teacher. Okay, practice. Let's practice what we just learned. Now we're going to use those theorems in our proof. There we go. We have a diagram, as you can see, lines intersecting. We're given, and we put down the given first. I always do. This is number 1, and number 1 is the given. So how am I going to get 1 equals 4? Well, I have 2 is equal to 3. I know that angle 1 is equal to angle 2, and I also know that angle 3 is equal to angle 4. And that's reason is VOAT. Or again, VAT, your choice. Check with your teacher. Vertically opposite angle theorem or vertical angle theorem. So 1 is equal to 2 vertically opposite angles. 3 is equal to 4 vertically opposite angles. And as a result, we have 2 is equal to 3. So from this statement, 2 is equal to 3. So if 2 equals 3, that means that angle 1 is equal to angle 4. And again, just you could say transitive, but there's a couple of transitives there, but we don't want to get hung up into, writing down transitive property twice. So 2 equals 3, there's 2 and 3 equal. So 2 equals 3, 1 equals 2, etc., etc. So that means that 1 is equal to 4. Number 2, again, the diagram, we can see that we were given that 5 equals 6 in our given. We had to prove that 1 equals 7. So again, let's put down the given. We'll take out from there the given, G-I-V-E-N. And how do I get 1 equals 7? Well, that angle 1 and 5 are a linear pair. And I also know that 6 and 7 are a linear pair. And that's the definition, DEF, of a linear pair. So, that be the case, they're a linear pair, then I know, because they're a linear pair, that angle 1 is supplementary to angle 5, and angle 6 is supplementary to angle 7. And that's because we have a straight angle. And because, notice now, we have 5 equals 6. So there's 5 equal to 6. Because they're supplementary, and because 5 equals 6, that means angle 1 is equal to angle 7 by SAT, supplement angle theorem. We just proved it on the previous page, but now I'm using it. I proved it, so now I don't have to do that proof. I just write down the statement. Again, these two pairs are supplementary with 5 equals 6. That means 1 is equal to 7. So SAT, supplement angle theorem. And I say that, but again, check with your teacher if you're allowed to say, do you have to write out supplementary angle theorem in words or just SAT? And number 3, let's look at this proof. We got this diagram. We're given that angle 1 is complementary to angle 3. That's a given. And we're also told that angle 2 plus angle 3 is equal to 90. So that's our givens. Now, how do I go about proving this? Well, if I have 1 and 3 is complementary, 2 and 3 add up to 90, so that means angle 2 is complementary to angle 3. That's based on the definition of complementary angles. Two angles that add up to 90 are complementary. And notice now that we have 1 is complementary to 3, 2 is complementary to 3. That means that angle 1 is equal to angle 2. Oh, I got ahead of myself. I forgot to look at this statement here. Not only do I have my givens, but I also have to look at what I'm going to prove. What am I trying to prove? That AC bisects BCF. So I just can't start my proof here and go. I got to know where what I got to end up with. So AC bisects BCF. So if AC bisects BCF, that means that these two angles, so if that's a bisector, that means 2 and 1 are equal. So I have to get 2 and 1 equal in order to get a bisector. So now, because they're complementary here, because 2 and 3 are complementary, because they're both complementary to 3, that means 1 equals 2 by complement angle theorem. And because 1 equals 2, that means that AC bisects angle BCF. And that's the definition of an angle bisector. Sorry about that, I got ahead of myself in doing this. I just looked at the complementary here and I jumped into this complementary. But I have to look at, when you're doing proofs, you have to look at what you're given and what you're going to prove. It's important to look at what you're proving. Make sure. And we have another proof here, number 4. This time, we're trying to get, we have a diagram. We're given that angle 2 is equal to angle 1. So that's a given. Now, we want to prove that 3 is supplementary to 1. So 3 is supplementary to 1. That means 3 and 1 are adding up to, going to add up to 180. So how do I get 180? I got to get 180 into this, out of this diagram. Oh, and I look around and I see that angle 3 and angle 2 are a linear pair. And that's the definition of a linear pair. So because I have a linear pair, that means I have angle 3 and angle 2 are supplementary, because that's a straight angle there. Straight angle. That's a straight angle there, so I have a linear pair, I have them supplementary. And because they're supplementary, I cannot substitute into this statements that's supplementary. So I have to say that angle 3 plus angle 2 equals 180. That's the definition of supplementary angles. So I have the angles adding up to 180. Now, because I have 1 and 2 are equal, so I can take the 2 and replace it with a 1. So I can take the 2 and replace it with 1. 2 is equal to 1, so 2, I replace 2 with angle 1, and that's the substitution. That's the substitution property. And because I got 1 and 3 adding up to 180, that means angle 3 is supplementary to angle 1. And the reason is definition of supplementary angles. So just a little proof, working the proofs around, making sure that, trying to explain to you how we get through these proofs. And we have a final page. Number 5, prove equal angles, equal pair of linear angles are right angles. So how do I do a proof on this? Notice the left side of the verb, I got an equal pair of linear angles. So that means if I got an equal pair of linear angles are two angles that form a straight angle, form a segment or a line. So we're given that angle 1 and angle 2 are a linear pair. There's the so I'm using this diagram to do the proof. And we're also told that they're equal pair of linear angles. So that's this information I'm doing here with this diagram is coming out of this statement. We just get used to doing that. but it takes a while. That's why students have trouble with proofs, because they get frustrated with them. But if you keep doing them often enough, everything begins to fit together. Now I got to show that 1 and 2 are right angles from here. We got equal linear angles are right angles. So how do we do that? Well, because we have a linear pair, that means angle 1 is supplementary to angle 2 because we have a straight angle. And that means because they're supplementary, angle 1 plus angle 2 adds up to 180 degrees. And that's the definition of supplementary angles. Now, because I got 1 and 2 adding up to 180, 1 is equal to 2, so I can say that I can replace 2 with 1. So now 1 is equal to 2, so I'm replacing 2 with the 1. I could have done replace 1 with the 2. I just elected to take angle 2 and make it angle 1, and that's substitution property. And notice now, angle 1 plus angle 1, that's 2 angle 1s. 2 angle 1s is 180 that's number 5, by addition. We're adding them together. And now we got angle 1 is 90 by division. And as a result, angle 1 is a right angle. Definition of a right angle. Because angle 1 is 90 degrees, angle 1 is right angle. That means if angle 1 is equal to angle 2 is a right angle. Again, from this statement, we have to draw a diagram, fill in the given, and what we're trying to prove. But that takes a while to learn how to do. But I have to do these proofs to show you how they're done. And number 6, the adjacent angles forming perpendicular segments are complementary. Adjacent angles, 2 angles that are adjacent, forming perpendicular segments are complementary. So here's a diagram. We got 2 adjacent angles. They don't overlap. They got a common arm, and they form perpendicular segments. There they are. We got to show that these adjacent angles are complementary. So we're given adjacent angles 1 and we're given the adjacent angles 1 and 2, and we also have that the segments AC and BC are perpendicular. So how do we go around showing that they're complementary? Well, we got to show that the adjacent angles, which are 1 and 2, are complementary. How do we get them complementary? Well, complementary means they add up to 90. So I got to get the angle, these 2 angles adding up to 90. Let's see how we do it. We got perpendicular lines, so angle ACB, because they're perpendicular, then angle ACB is a right angle. And that's the definition of perpendicular lines. Because angle ACB is a right angle, that means angle ACB equals 90 degrees. And that's the definition of a right angle. So because they're perpendicular, we got a right angle. Because they're right angle, they add up to 90. Now that angle ACB, make it a B, is equal to angle 1 plus angle 2. And it's called the angle addition property. These 2 angles add up to, so angle ACB added together, add 1 and 2 together, you get the angle ACB. And as a result, angle 1 plus angle 2 is equal to 90. So angle ACB is 90. Angle ACB is equal to 1 plus 2. That means that 1 plus 2 is equal to 90. And that's the transitive property of equality. Now we have, notice, we have them adding up to 90. So that means angle 1 is complementary to angle 2. Definition of complementary angles. Hopefully you can see the strategy or how I'm proving the statement. So I made up the diagram to fit this. So we have complementary angles that are perpendicular, forming perpendicular lines or segments, and we got to show that these two angles are complementary. And the last one, if two angles are equal and supplementary, then they must be right angles. So if two angles add up to 180 and they're both equal, they got to be 90 degrees each. But let's look at this proof. So let's go. The two angles are equal, so angle 1 equals angle 2, and angle 1 is supplementary to angle 2. Number 1. So that's the given. Now, because they're supplementary, that means that angle 1 plus angle 2 is equal to 180 degrees. Definition of supplementary angles. And we got 1 and 2, we want a right angle, and a right angle has 90 degrees. So angle 1, so angle 1 equals angle 2. So let's put a 2 here. Angle 1 is equal to angle 2. So I'm replacing angle 1 with angle 2, and that's the substitution property. And that means that if you add them together, you get 2 angle 2's is 180 by addition. And you got 2 angle 2's 180 divided by 2. Angle 2 is equal to 90 by division. And notice that angle 2 is a right angle. Definition of a right angle. What's a right angle? An angle that has 90 degrees. That means that angle 1 is also a right angle. You can make that statement there. Because they're equal, that means angle 1 is a right angle. Because they're equal. And we could say transitive property or substitution, or, you know. Again, that brings us to the end of some of the proofs on vertically opposite angle theorems, complement, SAT to CAT, which you will use in proofs coming up. And if you like my video, click on the like button, subscribe button, notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you very much for viewing my video. Bye-bye.